I picked Zig because it keeps systems programming sharp and readable. For image filters, that matters because we are working directly with raw pixels, memory, and performance-sensitive loops. WebAssembly makes this project much more interesting because the browser stops being just a front end. It becomes a real runtime where Zig code can process images live, while JavaScript handles the interface. I chose this project because it makes the full idea visible very quickly. You can upload an image, run filters, see the result instantly, and understand exactly why Zig and WebAssembly are a strong combination. In this updated Zig and WebAssembly image filter tutorial, we are not just showing the final app. We are also showing the new stacked filter workflow, the undo logic, and real browser screenshots so the story feels grounded from the very first frame. This is the running app in the browser. The user uploads an image, applies filters in the toolbar, compares the original and filtered canvases, and exports the result as a PNG. The key product change is that filters now compose. Instead of replacing the last result, each new filter uses the current image as input, so grayscale, blur, and sharpen can build a chain. Now we move from slides into the live app. Watch the stack in motion. The same AI-style image stays visible while the filtered canvas changes in real time. This quick section proves that the browser UI and the WebAssembly processing are already connected and working together. The undo story is simple and strong. Rather than trying to reverse each filter mathematically, JavaScript stores the applied steps, resets back to the original image, and replays the remaining operations in order. That design keeps the interface clean. Buttons can toggle filters on or off, the applied list can remove one step directly, and reset always returns to the original image without confusion. The screenshots also show why this matters visually. The same source image can produce a softened stacked look or a strong edge map, which makes the demo much easier to understand for viewers. Edge detection is the most dramatic example. Sobel reads strong pixel changes, Zig writes the magnitude back as grayscale, and the browser redraws the result immediately. Architecturally, the filter history lives in JavaScript, but the actual pixel work still moves through WebAssembly memory. That keeps the browser code responsible for state, while Zig stays focused on predictable image processing. In this build walkthrough, we move through the code that makes the app work. The front end is responsible for loading the image, reading canvas pixels, and preparing the browser controls. The important part is that none of that changes the filter math itself. It only prepares the data and the user flow. Now that you have seen the working flow, here is the from-scratch overview. I will not go too deep here. I just want to show the structure clearly before we move into the full crisp tutorial. We start with the browser user interface, connect JavaScript to WebAssembly memory, export the Zig filters, and then run the whole app live from end to end. Now the full crisp tutorial begins. We start with the idea of the app. Zig handles the image processing, while the browser handles the interface, file upload, canvas preview, and export flow. The next piece is the bridge. JavaScript reads the image pixels, copies them into WebAssembly memory, calls the Zig exports, and paints the processed result back into the filtered canvas. Inside Zig, each filter stays focused. Grayscale uses luminance weights, blur samples nearby pixels, sharpen uses a small convolution kernel, and edge detection uses Sobel to find strong changes. From there, the browser app becomes very practical. You can upload an image, test filters quickly, compare the original with the processed view, and export the result as a clean PNG.